Right, so this is physics. I have this question for you, which is saying figure 3.1 shows four forces acting on a submarine. The submarine is moving underwater at a constant speed. So at a constant speed, the submarine is going to have zero acceleration. So now we have these forces acting on the submarine. So we have the first force, which is called the normal force, which is A. Then B, it is called the friction force or frictional force. C, it is called the weight. So weight is a kind of a force. Then D, it is the driving force. The driving force. Question A. State which force A, B, C, or D is the weight of the submarine. So it is just C. So the answer we can just say C. That is the weight of the submarine. B. The submarine travels 36 kilometers in 2 hours. Calculate the speed of the submarine in meters per second. So we know that speed is equal to distance divided by time, where distance is going to be in meters, then time in seconds, and then speed is just going to be in meters per second. That is one thing that you need to know. So we need to convert distance, which is 36 kilometers into meters. Now 1 kilometer makes up 1,000 meters. So if I put 36 kilometers here, then I multiply it with 1,000 meters, I'm going to get 36,000 meters. So this one is our distance. Then as for time, if you are converting the hours into seconds, you need to get the number that have been given and multiply it with 3,600 seconds. So we can just say 2 hours multiplied by 3,600 seconds. Then the answer we are going to get here, it is just going to be 7,200 seconds. So this one is our time and this one is our distance that we are going to use to calculate the speed. So let's calculate speed. So speed is equal to distance. In this case, the distance, it is 36,000 meters divided by the time, which is 7,200 seconds. So when I divide, I'm going to get 5 meters per second. So this one is our speed. Let's move on to the next one. So the next one is saying, which is C, the submarine is powered by a small nuclear reactor. Ionizing radiation is released in the reactor. The reactor must be shielded to protect the crew from this radiation. State how exposure to ionizing radiation can affect the human body. So it can affect the human body by destroying the cells. So when you are exposed to radiations, those radiations are going to destroy the cells. Then apart from destroying the cells, they are going to cause the mutation to the cells. So by causing cancer or by destroying cells, it can cause mutation. When you are exposed to radiations, those radiations can cause mutation. Then Roman numeral number 2, suggest a material which can be used to shield a nuclear reactor and stop alpha radiation and beta radiation escaping. So to know the material that we are going to use to shield for these radiations, we need to use the idea about the penetrations. So since here we don't have the gamma radiation, so we're just going to consider these two, which is the alpha radiation and beta radiation. So alpha radiation can be stopped by a sheet of paper or a plastic. So this one here, it is a paper, which means the alpha particle can be stopped by a sheet of paper. But beta radiation can penetrate through the paper and can be stopped by a sheet of aluminium. So this one is going to be the aluminium. Right, so if the beta particle can be stopped by a sheet of aluminium, which means the good material to use to prevent the escaping of alpha radiation and beta radiation can be aluminium or lead, because lead can stop the alpha radiation, beta radiation, including the gamma radiation. So we can say lead or aluminium. So those are the answers. Thanks for watching.